Welcome to another episode of Businesstalk podcast. I am Deepak, your host for today's episode. We are honored and privileged to welcome Dr. Ramayya Krishnan, William W. and Ruth F. Cooper Professor of Management Science and Information Systems and Dean Emeritus at Heinz College and the Department of Engineering and Public Policy at Carnegie Mellon University as our distinguished guest on today's podcast. Dr. Krishnan has been a faculty member at Carnegie Mellon University since 1988. He first served as an interim dean of Heinz College in 2008 and went on to lead the college as a dean for 3 consecutive terms from 2009 to 2025. Dr. Krishnan received his education at the Indian Institute of Technology Madras and the University of Texas at Austin, where he earned a bachelor's degree in mechanical engineering and master's degree in industrial engineering and operations research, and a PhD in management science and information systems. A leading authority on digital transformation, technology management, and data-driven decision analytics. He has collaborated widely with firms and public agencies to harness technology and analytics for strategy and policy goals. His scholarly contributions spans AI, e-commerce, and information risk management. He has served as a department editor for management science and held senior editorial positions across several informs and information engineering journals. Dr. Krishnan's current research centers on AI measurement and evolution, particularly the implications of AI for the future of work. An accomplished academic entrepreneur, he founded the Master of Information Managed Systems and Management program in 1998, which grew from an inaugural class of 10 to over 100 students within a few years. Alumni of this program now hold leadership roles in major technology firms worldwide. Its data analytics track was selected by the US Army Futures Command in 2020 as part of his AI Scholars Initiative. In 2022, Dr. Krishnan and colleagues at Heinz College established the Decision Analytics and Systems program, a pioneering undergraduate minor that integrates system thinking, analytics, and experiential learning. Under his leadership, Heinz College earned the 2016 UPS George D. Smith Prize from Informs for Educational Excellence, making it the only institution to hold both the von Neumann Theory Prize and the Smith Prize. Over the past decade, Professor Krishnan has founded 4 externally funded research centers, securing nearly $100 million in research support. He was the founding faculty director of the Block Center for Technology and Society and now leads the AI Measurement Science and Engineering Center. He is a fellow of American Association for the Advancement of Science and Informs, an elected member of the National Academy of Public Administration, and a commissioner with the Atlantic Council's Geotech Center. Professor Krishnan also brings deep expertise in AI governance and policy. From 2022 to 2025, he chaired the AI Futures Committee of the National AI Advisory Committee to the President and the White House Office of AI Initiatives. He currently chairs the Responsible AI Academic Council of the Department of Defense Chief Digital and Artificial Intelligence Office and served as an ambassador to the UK Responsible AI Council. A distinguished alumnus of both the IIT Madras and the University of Texas at Austin, Dr. Krishnan served as the 25th president of Informs, the Global Operations Research and Analytics Society in 2019. Today, Dr. Ramayya Krishnan dwells into his pioneering research, Two Heads Are Better Than One, How to Operationalize AI with People, Processes and Trust, exploring how human collaboration, organizational processes, and trust are key to realizing AI's full potential. Let's not keep you waiting. Please join me in welcoming Dr. Ramayya Krishnan to the podcast. Dr. Krishnan, we are deeply appreciate your gracious acceptance of our invitation. It's an honor and privilege to have you with us today.
Well, thank you for such a kind introduction, Deepak, and I'm delighted to spend some time with you to explore this really important topic.
Thank you. Professor Herbert Simon's idea that two heads are better than one underpins this conversation. How do you interpret that insight in the modern context of human AI collaboration?
So, Professor Herbert Simon was a Renaissance scholar. I was very fortunate to have not only been inspired by him, but actually worked with him when I initially joined Carnegie Mellon in the late 80s. Um, Professor Simon addressed Informs in 1986 and gave this seminal talk on two heads are better than one at a time when expert systems was the dominant AI technology. And he called for how AI and operations research were two disciplines that were founded within 10 years of each other. Operations research came into being during World War II, that's 1945, and AI 10 years thereafter, 1955. And but they both have complementary goals and capabilities and methods. And his call at that time, in that age of AI, was how you could take the qualitative reasoning capabilities of AI and combine it with the quantitative reasoning and analytic capabilities of operations research and management science. In more recently, in the work that I've engaged in, and I've recently spoken about this topic, um, I've made the case that there have been these dramatic improvements in capabilities that that AI has brought to the table, particularly with the advent of generative AI. But if you combine predictive AI, prescriptive kinds of AI, and methods that came perhaps from operations research, and then combine that with generative AI, so predictive, prescriptive, and generative, all those capabilities, for them to be deployed in ways that would yield value to business or to society, there's really an opportunity for taking advantage of this two heads coming together again. AI with all its new capabilities, but it's a recognized problem today that many organizations are having difficulties in operationalizing AI to yield value. Operations research has had a long history of actually deploying decision technologies, and therefore, what I've called for are specific ways in which AI and OR in today's world, because both disciplines have advanced since Professor Simon spoke in 1986, but how the two disciplines might come together again in ways that are mutually synergistic and beneficial to society.
Professor, you often emphasize that successful AI adoption depends as much as on people and processes as on technology. What are some of the biggest misconceptions organizations still have about this balance?
I think this is a repeat in many ways of what we've seen in prior generations when there was innovation in digital technology. So even going back to the last major digital technology related innovation was, if you think of it as internet and e-commerce, and then after that mobile technology in various ways. I think there's always been the sense that technology alone and focusing on technology alone will not yield value, that you need to invest in the complements to technology. And those complements are processes and people. So you often hear people, process, technology. And I think um, there have been a number of studies going back to the early 90s that have actually documented that you need these complementary investments and perhaps even a rethink of how you actually um, operationalize business processes to generate value. And going back, way back to the advent of electricity, when steam was the dominant technology, it took many, many years for people to figure out they don't have to just keep what they were doing with steam and just add electricity. They had to fundamentally rethink the layout of shop floors and machining in new ways because the constraints that steam technology imposed were no longer constraints that applied in the context of electricity. If I might use that metaphor in today's world, um, new technology will require you to rethink how business processes function and also how the kinds of talent and skills that people need to have to be able to actually work on tasks which of these tasks are going to be done by humans, which of these are going to be done by AI, which of these are going to be done by humans plus AI. These are all questions that have to be simultaneously solved for, versus thinking of this purely as, hey, there's technology that has capability, I'm going to deploy it, and I'm going to immediately realize value. And that's why you have these informal rules of thumb that talks about technology, AI technology is only 10% of the real investment that needs to be made. 70% is in people and process, and maybe 20% is in enabling digital technology. So it's almost like an iceberg. So the tip of the iceberg is AI tech, but there's a lot of stuff beneath that needs to be dealt with and dealt with holistically if you're going to see value from deployment.
Professor, as you mentioned, many studies show that up to 70% of AI investment should be directed toward people and process transformation rather than technology. Could you unpack what that 70% practically looks like inside an organization?
So it's not like either or. So it's not like, 70% on people and process, 10% on technology. It's not that. It's about having a systems level view of how one thinks about workflows. And this the systems level view is a particularly important aspect of operations research and management science. It's actually one of the reasons why I think the two heads are better than one point is particularly relevant in today's world. That if you think of almost any system that delivers value, let's say think of an example. I'll use one from let's say the public sector, for instance, where people might, if you were a senior citizen, you might get social security payments, or you might have access to healthcare through health insurance. And this might happen in the private sector as well. In these systems, there is a workflow. And some particular steps in this workflow may be fundamentally rethought using AI. So, for instance, if I knew your demographics, if I knew your particular health conditions, maybe I can tailor some things for you that are specific to you in ways that are more personalized. But that's one part of a larger set of things that need to happen to actually deliver the service that is being delivered by the system to the individual in question. So when you think about workflows, you need to think about workflows as consisting of multiple steps. And these multiple steps, some of these steps may be done by a human. Some of these steps may now be candidates for automation via AI. Some of these steps may be candidates for augmentation between human and AI. And fundamentally, you may even rethink the sequence of steps that you might actually have to engage in. Let me give you one other example to make this point even more explicit. In the US, there's widespread use of electronic health records. So when you go to see a physician, if you were my physician and I came to see you, you as a physician are not only interacting with me, you have to fill in some information about the consult into the electronic health record. And the effort required to do that sometimes detracts from the physician's ability to pay attention completely to the patient. So oftentimes they may have a scribe who's a person who either takes notes during the course of the consult, or the physician will have to remember after the consult to dictate what actually transpired during the consultation so that a transcription of that consult is created, which then gets entered into the claim system and the electronic health record system. That's an example of a workflow. Now you have the emergence of something called ambient AI that actually can listen in on a conversation between me, the patient, and you, the physician, and at the end of the consult, actually, I've been in these, I've had a consult with my physician, and she brings up her phone. She asks you for permission to turn on the ambient AI. It listens in on the conversation. And at the conclusion of it, she has a summary of what that consultation entailed. She can review it. And upon her approval, it gets entered immediately into the electronic health record system or the claim system. Think about the workflow that existed prior to the AI and the workflow post the AI. You have one of the advantages is that the physician and the patient are able to have an interaction which the sole focus of the physician is on the patient and vice versa. Second is that what was done sequentially previously, with the physician having to remember what transpired during the consult and dictate, etc., is now done simultaneously. You have parallelized something that was done sequentially, thereby increasing efficiency. And that has saved between 6 to 8 hours per week for physicians. They call this pajama time because they often do this after they go back home. So this has been very beneficial, not only in improving the physician patient experience, but also reduce burnout for physicians because it's taken, given them back time that they otherwise would have involved, that they otherwise would have incurred in doing the kind of dictation. I hope this gives you a very concrete example of thinking about practical workflows and that you need to adopt a systems point of view and B, determine which tasks are to be done by whom, human AI or human plus AI, with appropriate governance, etc., to ensure that not only are processes made more efficient and effective, but you have the right level of oversight, like in this case, the physician approving the summary as being the right summary to get a responsible deployment of the AI.
Professor, trust plays a huge role in the acceptance of AI systems. How can leaders and designers build and maintain trust among employees who may fear automation or bias?
So let's pick up on the same example that I just shared with you, right? If I were a physician and I have to rely on this ambient AI that produced the summary, I have to have trust that the summary is actually a correct representation of what I had this consult with the patient. Is this a correct summary, right? So I think trust is critical. It's critical to adoption of the AI. And trust is a multi-dimensional construct. What do I mean by that? What I mean is it has to be correct. It has to be so there is accuracy. Is there bias? Is there aspects of the correct tone? Is the context correct? So it's not yes or no, but it's truly a multi-dimensional kind of construct, and it often also builds with experience. So, in other words, think about how humans interact, right? Let's say I get to know you, I ask you for advice, you give me advice, I act on it, and it turns out that you've given me good advice, then my trust in you grows. If you, on the other hand, you give me some advice that doesn't work out, I don't trust you as much, right? So I think it's not unlike that when you think about AIs as assistants that you're trying to rely on. And if it's a consequential task, so if it's like a Netflix recommendation for a movie and it gives you a bad recommendation, no big deal. But on the other hand, if it's something very consequential, like the summarization in a physician patient kind of conversation, so the effort that leaders have to undertake is there has to be a very significant investment in evaluation and measurement. That's why I think measurement and evaluation is critical to understand not only when it succeeds, but what are the failure modes of the AI, and to be able to help people understand when it can be relied on and when it potentially can fail, so that there is more complete information about the use of the AI. Because as people's, even the word AI, right, brings to mind it's artificial intelligence. This is on par with human intelligence. And then you have words like artificial general intelligence. So I think it sometimes creates in people's mind uh, almost a sense of that it's something that is totally reliable, and but that trust has to be earned, and it has to be earned on the basis of measurement and evaluation, and on the basis of lived experience. By which I mean the interaction has to be yielding trust. So those are some of the issues that are relevant.
Professor, AI evolution frameworks are becoming more sophisticated. What are the key dimensions like fairness, explainability, or robustness that you believe matter most in measuring AI's real world reliability?
So I think I'm glad these questions are building on very nicely on one another, because I just spoke about evaluation being a multidimensional exercise, and there are some particular challenges with generative AI, by virtue of the fact that it inherently is a stochastic system. What do I mean by that? The basic generative AI model that currently is dominant is what's called a next token predictor. And that next token predictor is done on the basis of stochastic or probabilistic kinds of estimates of what the next token should be, next word should be. Um, and these generative models, while they're amazing, as I'm sure you and I and everybody else who's listening has experienced, they can also create errors. Even there's a popular term, hallucinations, has entered our vocabulary, right? So when you do evaluations, um, they have to the let me step back. The traditional approach to evaluation has been that there have been these static benchmarks. This has been a traditional approach where there are benchmarks, you run the AI on these benchmarks, and then you test to see how well it does against those benchmarks. And these benchmarks try to probe these different dimensions of evaluation of the sort that we have talked about. The challenge there is that by virtue of these AIs training on a lot of everything that's out there, you have a problem called saturation that emerges, meaning that these benchmarks are also things that they train on, and therefore they can do really well on benchmarks, but they no longer become reliable signals of how fair the system is, or how robust the system is, or how reliable the system is. It's like, if I memorize everything and I go in and do an exam, do I really know this, or did I memorize this, right? So this idea of dynamic benchmarking, which is something that we've been working on at this center that I'm leading. It's a bunch of colleagues here at Carnegie Mellon. It's called the AI Measurement Science and Engineering Center, has been to really move the state of the art from static benchmarks to dynamic benchmarks. And the idea here being that there is a way in which you can test AI models and AI systems in ways that would allow for representative types of queries to be posed to them that are not static but are more dynamic, and then to have the evaluations of those responses from the model to be done in a way that can involve these multi-criteria evaluations using what's called a rubric. Now, an important aspect in this is not only going from static to dynamic, but also to expand the set of opportunities available to organizations that might not have large user bases to actually do this kind of testing of their AI models and AI agents. So, for instance, the OpenAIs, the Googles, the Anthropics of the world, they have very large user bases, but smaller and medium-sized enterprises do not. So, for them, could AI agents serve as proxies for users to pose queries? Could we have AIs as judges to judge the responses? So, the next generation of evaluation is really moving from not only from static to dynamic, but potentially using these approaches that combine simulation that has been um, vetted and verified, combined with the use of AI itself in the process of doing evaluation. So all of this is very much current research, so I shouldn't um, predetermine what the likely results of this will be, but I think we are in a very important and exciting phase of how the state of evaluation itself is changing. And all of this is just what I just mentioned was for models. And of course, the new buzzword that's gotten a lot of excitement has been agentic AI, and that creates an even larger set of evaluation questions and measurement questions as to how do you measure and evaluate agentic AIs, which I think are going to be very, very important to understand as more and more organizations seek to deploy them.
Professor, can you share an examples where AI initiative failed not because of poor algorithms, but because people or processes factors were overlooked? What were the lessons learned?
So, I mean, there are many such examples that are out there that you could think of. Um, you could imagine, the following simple case. Right now, they've become much better, but if you go today to board a plane, um, they actually check your biometrics. They check your face, and that automatically determines whether you're approved to go forward. That's facial recognition, right? That's an AI. Now, earlier generations of facial recognition actually had challenges with people with darker skin, people who had different features than perhaps the original group of people that were part of the training data sets, which tended to be more white people and not as many people with darker skin and different features. So in that case, if you imagine deploying an AI without completely doing the robustness testing, you have a number of false positives that result in the individuals being screened, incurring additional cost, incurring additional effort. Now, in the example that I gave you, maybe it's not as significant, but if you think of very consequential decisions being made based on AIs that are not as not that have not been trained on representative sets of data, where questions of who gets insurance, who gets an interview for a job, all of these this is what led to a major concern maybe in the last, it's now close to a decade, but over the last 5 6 years, a particular focus on saying how might we evaluate AIs for fairness, especially if they're being deployed in consequential tasks. Could they then result in um, you know the recruiting example I can give you is because male software engineers had been hired to date, would there be a preference for more male software engineers being given chances for job interviews than, say, females? That's a very concrete example that's actually been documented. Now, is that the case today? Is certainly we have learned from that and improved our systems, but it speaks again to really trying to understand the entire system as a whole, learning what it is these AIs were trained on. And this is where there's a lack of transparency as to understanding what these AIs have been trained on. All we are typically left with is being able to evaluate them as black box systems. In testing, you have black box, white box, and gray box. White box is where everything is known and visible. Black box is where it isn't, and gray box is in the middle. Most AIs today, including the ones from OpenAI, Anthropic, Google, etc., are black box systems. The open weight models like the Llamas, the DeepSeek, give you some gray box kind of access, but you don't really know what they were trained on either. So there are only very few models where you have complete visibility in terms of knowing all the things that went into training the model, the weights of the model, and potentially trying to understand the behavior of these models. On top of it, these models tend to be very large and complicated. So I think these are some of the challenges with these AIs. And by virtue of those, if you rush them into deployments, and those are the examples I gave you of recruiting or these consequential settings, then you had failures. And those failures actually came from failures of the AI. And you needed to have potentially, if you chose to do those, you needed to have compensating ways in which business processes or people, in combination with one another, where you had people having decision rights to overrule the AI. If you had that, then you potentially could have dealt with some of these problems. But I hope I've given you a flavor for where failures took place, why some of those failures took place, potentially how they could have been mitigated, either by better testing or evaluation, or deploying systems in a way where you recognize there is going to be failure, and how might we deal with those failures by combining people with AIs where people have decision rights and the capacity to overrule the AI where appropriate.
Probably regulatory sandboxes are emerging as important tools for responsible AI innovation. How do they help balance experimentation, safety, and policy learning in high-stake sectors like healthcare?
So, I mean, the idea of a regulatory, by the way, there are two kinds of sandboxes. Technical sandboxes of the sort I was referring to when I was talking about evaluation of AIs, and then regulatory sandboxes. Regulatory sandboxes are, in effect, trying to promote innovation in a way where you can get under very specific settings and provisions, um, a, a pause in terms of the existing regulations that apply, so that you are free to innovate for a period of time without having specific regulations that might potentially be a brake on innovation. So the UK was an early proponent of regulatory sandboxes. The White House AI Action Plan has called for regulatory sandboxes in the US. Um, but the idea is basically one where you get, if you will, a period of time where you can deploy an AI in a setting where existing regulations don't necessarily prevent you from deployment, and therefore allow you to try something out, but with safeguards in place, um, to ensure that there's an opportunity to balance innovation with regulation. So it's an attempt at saying, um, we absolutely want to do deployments of AI in consequential settings. For that, you need to do a lot of testing of the AIs from a technical standpoint. That's technical sandboxes. But organizations may be reluctant to deploy the AI because of the regulatory constraints that apply. So let's give organizations a pause or a break on regulatory constraints under very specific guidelines and oversight, so that they can try this out to see whether the benefits are greater than the cost. So that's the concept of a regulatory sandbox. And the jury is still out. I mean, just so that with regard to exactly how effective they've been at promoting this balance between innovation and regulation, both in the financial sector and the health sector. Those are the two sectors where they believe that there might be this opportunity to strike this balance.
Professor, when introducing AI-driven decision systems, how should organizations redesign workflows and incentives so that human judgment complements rather than conflict with AI insights?
So, I mean, this is this is very much where context matters, right? So, when you talk about AI-driven decision systems, let me give you two very different examples. Suppose you have an autonomous vehicle that is, and Waymo just announced here in the US that they're going to allow autonomous vehicles in specific markets to drive on highways. Um, are those decisions systems that are deployed in those vehicles? The answer is absolutely yes, because it's navigating traffic, it's making numerous decisions like humans do when they're driving, right? Um, in contrast, let me choose something like loan granting. Should I give you a loan when you apply, or somebody else a loan, based on very different cases, right? One is autonomous vehicles, the other is loan granting. You could imagine healthcare, you could imagine, in job recruiting. So let me choose the one that is perhaps more socio-technical in flavor, which is something like when somebody applies for a job, how do you process that kind of information? On the one hand, the sheer scale of the number of, let's say, the applications that come in for a job posting may be such that that is beyond the capacity of just having humans just do that first level of processing. So the question is figuring out where you want to deploy the AI and for what purpose. So in the first case, if you think of the funnel, um, this would be like at an early stage in the funnel, being able to do that processing of resumes. Now, you want to do this in such a way that you don't commit errors of commission or omission. These are both false positive and false negative type of errors of who gets advanced. Either you don't want to advance people you should not be advancing, nor do you want to exclude people that you should be advancing, right? Both those cases. And there's a lot of work to be done in terms of testing and robustness and measurement and evaluation to see if that can be done right. You also want the AIs to be resistant to malicious type of submissions, because people know there's an AI being used. How do I know how to defeat the AI so that I can get it past the AI? So you have to think about robustness testing, both in an adversarial setting as well as in terms of robustness testing of the sort that I've just been talking about. The second phase is where you might get feedback and insights from the AI, but this is human plus AI. So in the first case I'm talking about is scale demands just an AI based intervention. A second case might be where you might get inputs from the AI based on what the AI has by way of a recommendation, but the decision maker is the human. So, in other words, this is augmentation, but with decision rights being resident with the human. In the first case, the AI had decision rights as to determine which resumes to advance and which ones to hold back. In the second case, following an interview. By the way, there's some very recent work that's exciting where people were given the option of either choosing a human to have a voice interview with or an AI. And it turns out that in this particular paper, this was for jobs to serve as customer service reps. A majority actually chose to do a 10-minute voice interview with a voice AI. And then, based on that voice AI based interview, which generates a transcript, which is then evaluated by a human. So the scale is dealt with the AI, but the transcript is processed by a human to decide whether they get advanced or not. They found that people who went through the voice AI channel, if you will, had greater likelihood of job acceptance and greater retention than the ones that went through the human channel. So, in this particular example, what I'm offering to you is you could imagine some steps being done by AI alone, some steps where the AI does some part of the work, but the rest is actually being done by the human. So, figuring out what steps should be done by human alone, what should be done by AI alone, what should be done by human plus AI, that's the design problem. And that, to bring us back to the title of our discussion, is really where the two heads are better than one come together again. You need a systems point of view. You need to have you need to be able to make decisions about how to take workflows and decide where AI is best deployed and how it should be deployed.
Professor, from your research and experience, what governance mechanisms are essential to ensure ethical and sustainable AI use within both public and private institutions?
So that's a very broad question, right? Because, by the way, just 2 days ago, we had an AI and energy summit at CMU, all right? Um, you can ask this sustainable, you can interpret sustainability and ethical use of AI in terms of the production process for creating the AI itself. Um, is it sustainable in terms of energy, in terms of water, in terms of these kinds of resources? So I think you have to again take a systems point of view in thinking about the AI, first asking the question, how was it produced to begin with, right? And if you think about how it was produced, um, there are questions related to the energy consumption that the AI will require, as well as the other kinds of resources that are scarce. So, where you locate these data centers, where you produce the AI becomes a really important factor. So, that's one aspect of where do you produce the AI. Then, when you deploy the AI, how do you do that in responsible and ethical ways? And I think I gave you an example in the healthcare context of how that deployment of the AI, where you use the AI for benefiting the patient physician engagement, but the summarization by the AI was input to the physician for her to determine and sign off on. So the governance took place there so that ethically you had the human physician in charge of actually assessing and determining if that summary was correct. And in so doing, you not only gain the efficiencies that I've already outlined and the benefits that accrue to the physician, but also an improvement in the physician patient relationship. In the recruiting example, I gave you again an example where you want to make sure that the AI that's processing resumes that come in, that errors of commission and omission, having a mechanism to actually report on who was left out and who was included, that being auditable becomes a mechanism by which you can actually check to see if there are patterns with regard to certain people, either with in terms of educational background or rural areas or different types of accents that tend to get screened out versus those that get included in. Um, there's some interesting work that we have done that also looks at not just AIs and the potential kinds of bias associated with the deployment of a particular AI, but imagine different AIs that share a level of correlation in terms of how they function. So, if you are a person who's applied for a job with firm A or firm B, if both those firms are using AIs, and I get denied by both firms because there is a systemic error in these AIs, that's a different kind of risk. That's called a systemic risk. This can happen actually in finance as well, where everybody is trading using AI. But if they're all using the same AIs and the AIs are getting them to make the same kind of decision, that could potentially result in a systemic kind of movements in the market, either up or down. That is a systemic kind of risk. So there are different kinds of risks. One is the kind of risk where I talked about type 1, type 2 type of errors or issues of omission and commission. The other is systemic kinds of risks. And then the issue of how do you ensure through governance that either you have auditing of the sort that I mentioned, uh, very detailed emphasis and commitment to measurement and evaluation on these different dimensions, and then process mechanisms where appropriate, recognizing failure modes to have the human actually be in charge. I think these are a portfolio of mechanisms to address uh, some of the questions that you talked about. I mean, it's a big topic. I mentioned a few things in the context of sustainability and a few things in the context of ethical governance.
Professor, I would like to conclude this episode with one last question. Looking ahead, how will the interplay of human expertise, process design, and trust shape the next decade of AI policy and deployment globally?
I think you're asking all these big questions that take long, that demand long answers, and I have to limit myself to a short answer. I think there are some really fundamental and very interesting opportunities that AI is going to enable. Even this question of human expertise, right? Um, what we have thought about as expertise, how will that change? Um, the this goes back even perhaps to an earlier generation of technology, right? At one time, um, being able to do arithmetic in your head was a kind of expertise. Um, and in fact, since we both grew up in India, this is one of those things that you grew up learning the tables and fluency in basic arithmetic. It was something that was taught very early on. Um, but then, if you think about the emergence of very reliable calculators, very reliable technology that can do this arithmetic for you. One of the interesting questions is does that shift the boundary of what you outsource, as it were, to a machine versus what you deem to be core to human expertise? So I think we are going to see some interesting changes in that boundary. So, for instance, you have something called Alpha Evolve that Google DeepMind has developed that's developing new algorithms. So I think science, um, what constitutes very interesting kinds of scientific inquiry, I think the human is still the person asking and posing hypotheses and questions, but the how it gets done, increasingly AI is supporting the human. In the previously you had to do not only the asking of the question, but you also had to figure out the how. Now you're seeing both these elements being supported in different ways by the AI. So, to the first part of your question about human expertise, that itself, I don't think is a constant, is my main point. I think that itself will change. The second is that if that changes, and if you think about the kind of workflows, I think the question of, and all of these is a question of what time scales will this happen over? What is going to happen over the next 1 to 3 years? What's going to happen over the next 5 years? I don't have a crystal ball. I don't know, how the world is going to change. But certainly, I think it's going to be very interesting to see how new demands for new types of work will emerge, which in turn will require new business processes, new workflows, along some of the lines of what we have already talked about. So I think some of these things that you're assuming to be fixed, like human expertise, processes, I wouldn't think they need to be fixed. I think they themselves will change in light of the technology itself changing. And policy will in turn be a determiner of how all of these things get jointly determined. So the rather than give you a specific answer about, okay, this is what it's going to be over the next X years, I don't know. What I can tell you is that the way in which, and learning from history, the way in which technology is going to induce changes, in this particular case, this particular technology, I think there's going to be changes in how we view human expertise. And it's going to raise some fundamental questions for us in what type of education we want to impart to children in K through 12, to people in universities. I think some fundamental questions related to what we see as really important aspects. For instance, critical thinking, learning to learn. These things become really important if the capacity of the AI to do programming increases considerably. That's another example. The earlier human expertise, is it about coding or is it about supervising the coding, becomes a question. So, in other words, when you think about human expertise, I wouldn't assume it to be fixed. Similarly, I wouldn't assume work and workflows to be fixed. I think that's going to evolve. So, I think we're in for a very interesting co evolution of technology, of policy, of human expertise. And I think this is going to have really interesting implications. And depending on how we choose to govern it, those implications could have really great upside opportunities. Or if we don't govern it well, it could potentially have downside opportunities as well. but it's going to be interesting. We are in for some very interesting times over the next 5 to 10 years. So buckle up.
Thank you, Dr. Krishnan, for such insightful conversation. Today's discussion reminded us that the real power of AI lies not in technology alone, but in how we weave it together with human insight, trust, and purposeful design. From balancing innovation with evolution to rethinking people-centered processes, your perspective shed light on what it truly takes to turn AI into sustainable value. To our listeners, thank you for joining us in exploring how thoughtful collaboration between humans and intelligent systems can shape a more fair, reliable, and impactful digital future. Until next time, keep asking the important questions and keep bridging minds and machines. We truly appreciate your time, Dr. Ramayya Krishnan. Thank you for joining us.
Thank you, Deepak. Thank you for the opportunity, and thanks for your leadership in convening these really interesting episodes. Take care.
Thank you.